Welcome everyone. Today, we're going to explore how Internal Corrosion Direct Assessment or ICDA, and External Corrosion Direct Assessment or ECDA, can serve as practical alternatives to traditional inline inspection, commonly known as ILI. These methods are recognized by NACE standards SP0208 and SP0507 and are increasingly accepted by regulators. Our goal is to understand why these approaches are important, how they work, and why they can be more cost-effective and flexible compared to ILI. Pipeline integrity is critical for safety, environmental protection, and regulatory compliance. Traditionally, operators have relied on ILI tools to inspect pipelines internally. While ILI provides comprehensive coverage, it comes with significant limitations, high costs, operational complexity, and the need for pipelines to be piggable. Many older pipelines or those with complex geometries cannot accommodate ILI tools, which creates challenges. This is where ICDA and ECDA come in as viable alternatives. Pipeline integrity is essential for safety, environmental protection, and regulatory compliance. Traditionally, operators have relied on inline inspection or ILI tools to detect internal corrosion and anomalies. While ILI provides comprehensive coverage, it comes with significant limitations such as high cost, operational complexity, and the requirement for pipelines to be piggable. Many older pipelines or those with complex geometries cannot accommodate ILI tools, creating operational challenges. This presentation introduces Internal Corrosion Direct Assessment or ICDA and External Corrosion Direct Assessment or ECDA as practical alternatives to ILI. These methods, defined by NACE standards SP0208 and SP0507, offer structured, risk-based approaches that focus on predicting and assessing corrosion at the most susceptible locations rather than inspecting the entire pipeline length. By integrating engineering analysis, historical data, and targeted field validation, ICDA and ECDA ensure safety and compliance while reducing costs and minimizing operational disruptions. ILI is not always practical for all pipelines. Some pipelines have small diameters, sharp bends, or flow restrictions that make pigging impossible. Offshore and remote locations add logistical challenges and costs. Additionally, operators face budget constraints and need solutions that minimize operational disruptions. ICDA and ECDA address these issues by focusing on high-risk areas and using predictive models and indirect inspection techniques. These methods allow operators to maintain integrity standards without the need for expensive modifications or downtime associated with ILI. What are ICDA and ECDA? ICDA Overview, ECDA Overview. Let's look at what ICDA and ECDA are. ICDA focuses on internal corrosion, while ECDA targets external corrosion. Both methods use structured processes involving data collection, analysis, and targeted field validation. Instead of inspecting every inch of pipe, they identify and examine the most susceptible locations, making them efficient and cost-effective. ICDA stands for Internal Corrosion Direct Assessment, which evaluates internal corrosion risks in liquid petroleum pipelines. ECDA stands for External Corrosion Direct Assessment, which targets external corrosion threats on buried pipelines. Both methods follow structured processes involving data collection, analysis, and targeted field validation. Instead of inspecting every inch of pipe, they identify and examine the most susceptible locations, making them efficient and cost-effective. These approaches rely on engineering judgment, historical data, and advanced modeling techniques to predict corrosion-prone areas accurately. ICDA is designed for pipelines that transport liquid petroleum and are normally full of liquid. It uses flow modeling to predict where water or solids might accumulate, as these areas are most prone to internal corrosion. The process includes 4 steps: pre-assessment, indirect inspection, detailed examination, and post-assessment. This systematic approach ensures that if high-risk sites are corrosion-free, the rest of the pipeline can be considered safe. ICDA integrates hydraulic modeling, operational history, and physical pipeline characteristics to identify corrosion threats effectively. ECDA focuses on external corrosion threats, particularly on buried pipelines. It involves indirect inspections such as close-interval surveys, CIS, direct current voltage gradient, DCVG, and alternating current voltage gradient, ACVG, to detect coating defects and assess cathodic protection effectiveness. After analyzing data, operators perform targeted digs at locations most likely to have corrosion. This method reduces unnecessary excavations and optimizes maintenance resources. ECDA also incorporates environmental data, coating condition assessments, and cathodic protection performance to provide a comprehensive view of external corrosion risks. How they compare to ILI, technical basis of ICDA and ECDA. Now let's compare these methods to ILI and understand their technical foundation. ICDA and ECDA are credible alternatives because they are based on sound engineering principles and validated through field data. ILI provides full coverage but at a high cost and requires piggable pipelines. ICDA and ECDA, on the other hand, offer targeted inspections, lower costs, and flexibility for pipelines that cannot accommodate ILI tools. While ILI gives a complete picture, ICDA and ECDA provide sufficient assurance of integrity when applied correctly, especially for low-risk or unpiggable segments. These methods complement ILI by extending inspection intervals or focusing on specific threats, making them valuable tools in a comprehensive integrity management program. ICDA relies on hydraulic modeling to predict internal corrosion locations based on flow patterns, water dropout, and solids accumulation. ECDA uses electrical survey techniques to identify coating holidays and assess cathodic protection. Both methods combine engineering judgment, historical data, and field validation to ensure accurate results. This scientific foundation makes them credible alternatives to ILI and ensures that integrity assessments are based on sound engineering principles rather than assumptions. Next, let's look at the advantages and limitations of ICDA and ECDA compared to ILI. The biggest advantage is cost efficiency. ICDA and ECDA eliminate the need for expensive pigging tools and associated operational downtime. They also provide accessibility for pipelines with complex geometries or older designs. These methods integrate seamlessly with GIS and risk-based integrity programs, enabling operators to prioritize resources effectively. Additionally, ICDA and ECDA allow for targeted excavations rather than full-line inspections, reducing environmental impact and operational disruptions. ICDA is not suitable for pipelines with continuous water phases or unpredictable corrosion patterns. ECDA requires accurate cathodic protection data and knowledge of coating conditions. Both methods depend heavily on data quality and qualified personnel. If these prerequisites are not met, the reliability of the assessment may be compromised. Operators must ensure robust data collection and adherence to NAE standards to maximize the effectiveness of these methodologies. Finally, let's discuss regulatory acceptance and how these methods fit into risk-based programs. ICDA and ECDA are recognized by NAE standards and accepted by regulatory bodies such as PHMSA as part of integrity management programs. They can be used as alternatives to ILI when justified by risk assessment and documented in compliance plans. This regulatory endorsement gives operators confidence in adopting these methods and ensures that integrity management practices align with industry best practices. ICDA and ECDA fit perfectly into risk-based integrity management frameworks. They provide data for risk ranking, maintenance planning, and reassessment intervals. This integration ensures that resources are allocated to the highest risk areas, improving overall pipeline safety and reliability. By combining ICDA and ECDA with other integrity tools, operators can achieve comprehensive risk management without excessive costs. Let's wrap up with a cost comparison and summary. ILI involves high upfront costs for tool rental, pipeline modifications, and operational downtime. ICDA and ECDA, while requiring engineering expertise and field validation, are significantly less expensive and allow for targeted excavations rather than full-line inspections. This cost advantage makes them attractive for operators managing large pipeline networks and seeking efficient integrity management solutions. ICDA and ECDA are credible, cost-effective alternatives to ILI for pipeline integrity management. They require accurate data and skilled personnel but offer flexibility, efficiency, and regulatory acceptance. For unpiggable pipelines and targeted integrity checks, these methods provide a practical solution that aligns with modern risk-based approaches and industry standards.